Welcome to another statistics video. In this video, we are going to talk about quartiles, the 5-number summary, and box plots. So let's get started. So when we talk about a data set, and let's say we just have a data set, we'll come up with a generic one here. The point of quartiles is to take the data set and split it into two pieces. So I have a lower half of data and an upper half of data, and then find the median of the lower half and the upper half. And what that does is it's going to take that data set and it's actually going to split it into four pieces. Quartiles means four pieces. So we're going to have something that we're going to call quartile 1. We're going to have quartile 2, which is actually our median. And then we're going to have quartile 3. Now, quartile 1 is going to separate the lowest 25% of data from the top 75%. The median is the number that's right in the middle. So that's your halfway mark. That's your 50%. It separates the bottom 50% from the top 50%. And then quartile 3 is going to separate that top 25 from that bottom 75. And so we've got this data set. The first thing you got to do is put all the data values in order. I like to go from smallest to biggest. And then what we're going to do is we're going to find the median. And that's quartile 2. So in this case, my median's right here. It would be the number between 3 and 4 because we have two numbers in the middle, right? I've got 4 in the bottom and 4 in the top. 4 numbers in the bottom, 4 numbers in the top. So that quartile 2 would be 3 plus 4 divided by 2 is the average of those, which is going to end up being 3.5. So now we've got this lower end of data and this upper end of data. So quartile 1 is the median of the bottom half. So if I were to look at this data set, I want to find what's in the middle. And right now I've got two numbers in the middle. So for this data set, my quartile 1 would be what's in the middle of 2 and 2, which is going to be 2. Quartile 3 is going to then be the median of the top half of the data. So I'm looking at this top half here. The median is going to be the number in the middle. In this case, my quartile 3 is what's going to live between 4 and 5, which is going to be the value 4.5. So there's my quartiles. And what that's saying is that the median separates the lower 50% from the upper 50%. So notice I got half of the values in the bottom, half the values in the top. The number that was in the middle here, which in this case was 2, separates that bottom 25% of data from the top 75% of data. And then the value that lives between here, which is our quartile 3, which was 4.5, separates that top 25% from that bottom 75%. So let's look at another example. Suppose we have this example and we want to find quartiles. So we're going to start by splitting the data set in half. So we're going to count how many we have. We have 24 data sets of data values, which means 12 have to live in the bottom half. And 12 have to live in the top half. So there's my halfway mark, and I like to draw that out so I can visually see it. So quartile 2 is going to be what lives between 53 and 54. So I could find that average, and that's going to be 53 and a half. So to find quartile 1, I got to figure out where the median of this lower half of data is, the lower values. So I've got 12 values here. So if I think about that middle, it's going to live between here. I got 6 values below, 6 values above. So I got to find what's in the middle of 41 and 43. That would be 42. So the value 42 separates that lower 25 from the upper 75. And then quartile 3 is going to do the same thing. So there's my divider. I've got 6 values here and 6 here. So I need to know what lives between here. So I could take 59 plus 61 divided by 2, and I'll get the value of 60. So there's my 3 quartiles. Now we can branch this out to talk about something called the 5-number summary. And the 5-number summary is really just the quartiles and then the minimum and the maximum values. And that information together gives me enough of information from the data set to create what's called a box plot. So we said that quartile 1 was 42. The median, which is quartile 2, was 53.5. And this was 60. So our smallest data value was 36, and our largest one was 43. Going back to our data values. 36, I don't know where I got 43. Sorry about that. That's 75. So let's take this information and let's draw a standard box plot. So this would be our standard. So I'm going to start with some kind of scale along the bottom. My smallest number is 36, so maybe I'll just start at 30, 40, 50, 60, 70, 80. So how do we draw a box plot? Well, we start with the box. The box is made up of the quartiles. So we got quartile 1 at 42, and then quartile 3 at 60, with the median at 53.5. And the median is just going to be that line in the middle. And I do like to label these if I'm doing these by hand. For standard box plot, we're going to next put a dot at that minimum value, which is at 36, and the maximum, which is over here at 75. And then all we do is we connect with a whisker the box to the smallest and the box to the biggest. So that would be our standard box plot. Now, we can also use this information to figure out outliers, and outliers are going to come from the modified box plot. So let's talk about that. So I'm going to draw my scale again. And my box is going to look the same. It's still made up of the quartiles with the median represented by a line in the middle. So quartile 3 is still 53.5. Sorry, that's quartile 2. Quartile 3 is 60, and quartile 1 is 42. But then we've got to figure out boundaries for outliers. And that's going to come from what I call fences. And fences is going to use something called the IQR. And the IQR is really how wide that box is. So it's the distance between quartile 3 and quartile 1. So in this case, if I look at my IQR, I'm going to take 60 and I'm going to subtract 42. And that's going to give me 18. So to find my fences, I'm going to take quartile 1, which is 36, and I'm going to subtract 1.5 times the IQR. And that's going to give me a boundary over here on the left. That's why I'm using that quartile 1. I'm going to take 36 minus 1.5 times the IQR of 18. And I'm going to get 9. And that's going to be way down here. So I would like to draw a little fence, and I'll do it in a different color. And then to find the upper boundary, I'm going to take quartile 3, which is this side. Think about your box like a house, and I'm sectioning off my house. And I'm going to add 1.5 times the IQR. Quartile 3 was 60. So quartile 3 plus 1.5 times the IQR. So I've got 60 plus 1.5 times the 18. And that's going to give me 87. So that fence would live over here at 87. Let's do that in a different color too. Okay, so then what we would do is we would take all of our numbers and we would draw to the minimum and the maximum within there. So our minimum is still 75. Our maximum is 75. Our minimum is 36. So in this case, everything is going to look the same. Now, if we would have add a value, let's pretend this was not at 75. Let's pretend it was at 95. Okay, that would change our box plot. Now the smallest number inside of that fence would actually be a 69, which means that this guy would go only out to 69, which would be about right here. And then that bigger value of 95 would be a dot outside. And we would say because that value is so far away from everything else, it lives outside of those fences because it's 1.5 times the IQR away from that quartile. And we would say this guy is definitely an outlier.